In this video, we're going to discuss distance formula and midpoint formula. So first we will talk about distance formula. Distance formula gives me the distance between points A. The point A has a coordinate x1, y1, and point B has a coordinates x2, y2. The distance between point A and point B is given by AB equal to square root of x2 minus x1 squared plus y2 minus y1 squared. This actually is derived from the Pythagorean theorem. So if you have a point A with the coordinates x1, y1 and point B with the coordinates x2, y2, and we are trying to find the distance between them, we can go ahead and draw a right triangle here, and we can call it C. And this distance would be x2 minus x1, because this is your x1 and this is your x2. And here's your y1 and here's your y2. And this distance will be y2 minus y1. So leg squared plus leg squared equal to hypotenuse squared. So we can say AB squared is equal to x2 minus x1 squared plus y2 minus y1 squared. And to find AB, we can go ahead and do the square root on both sides, and we will end up with this formula for the distance formula. Okay. So it is used to find the distance between 2 points on a coordinate plane. First example, find the distance between the following. So first of all, I'm going to label them as x1, y1, x2, y2. Each coordinate point, each point on the coordinate plane has an address with a x component and a y component. Sometimes students forget which one is x, which one is y. Think about alphabets. In alphabets, x comes first and then y comes later. So the first coordinate is your x coordinate, the second coordinate is the y coordinate. The reason why I'm distinguishing as x1, y1, x2, y2, to make sure that I recognize and understand there's two distinct coordinates and I'm trying to find distance between those two coordinates. So let's go ahead and plug them into the formula. So I'm going to call this is point A, this is point B. The distance AB will be x2 minus x1 squared, negative 4 minus 3 squared, plus y2 minus y1 squared. And y1 is negative in itself. There's a negative in the formula, and y1 is negative in itself, and that will actually become a plus. So square root negative 4 minus 3 is negative 7 squared plus 3 squared. Negative 7 squared is positive 49 because the negative gets squared. And 3 squared is 9. Square root of 49 plus 9 is 58. So square root of 58. Now, is it possible to break the square root of 58? Can I simplify it any further? Let's see. 58 divides evenly with, let's see, no, with 2. 58 divided by 2 is 29, and we cannot break 29 any further. So we would just leave it at this point. We can also approximate it in terms of decimals. That would be square root of 58 is approximately 7.62. So 7.62 units is the distance between the point A and point B on this plane. Okay, next example. So again, I'm going to start by labeling the points x1, y1, x2, y2. And this is my point A, this is point B. And I'm trying to find the distance between these 2 points. Let's go ahead and plug them into the formula. X2 minus x1 squared plus y2 minus y1 squared. And x2 is negative 6 minus negative 5 squared plus y2 is negative 6 minus negative 2 squared. So it turns out to be negative 6, and the two negatives here will actually become a positive. Negative times negative is a positive. So plus 5 squared plus negative 6 plus 2 squared. Turns out to be negative 6 plus 5 is negative 1 squared. Negative 6 plus 2 is negative 4 squared, which is square root of 1 plus 16, and leaves me with square root of 17. If I'm able to simplify it further, I would do that. If I'm not able to simplify it further, I would leave it at this point, and let's double check. Negative 6 plus 5, which is negative 1. Negative 6 plus 2 is negative 4. Negative 4 squared is 16. Negative 1 squared is 1. Yep, that is square root of 17, and there we go. Next example. find the distance between these 2 points. The points have radical notation. Instead of giving me decimal form, I'm giving the radical form, and that's okay. I'm gonna still do the same thing, label them as x1, y1, and x2, y2. And this is point A and this is point B. Doesn't matter which one you call A, which one you call B, because the distance does not really change. Let's say, for example, from my house to our campus, or from campus to my house, the distance does not change, it stays the same. So x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Do not forget to follow the order of operations. So 0 minus negative root 5 squared plus root 7 minus 0 squared. Now this negative times negative will become a positive. Root 5 squared, square root of 5 squared would be just 5, because root 5 times root 5 is root 25, which is equal to 5. Plus root 7 squared is just 7, and it turns out to be that would be square root of 12. And I know how to simplify square root of 12. We can pull out a 2 and 3 stays inside. 2 root 3 is what we're left with. Next, we're going to talk about the midpoint formula. The midpoint formula is the midpoint formula gives us the midpoint of two other endpoints. So the coordinates of midpoints are labeled as x3, y3. Usually we give it a letter C unless there's another letter given, just to label it. So x3, y3 are the coordinates of midpoint, and the endpoints are x1, y1, and x2, y2. The midpoint is given by add the two x coordinates and divide by 2, and add the two y coordinates and divide by 2. So x1 plus x2 over 2, y1 plus y2 over 2. x3 equal to x1 plus x2 over 2, y3 equal to y1 plus y2 over 2. So here's the question we are going to look at. It's a problem. Find the midpoint of 7, 3, and negative 1, negative 3. So how do I find the midpoint? First step, I'm going to label them as x1, y1, x2, y2. In the next step, I'm going to find the coordinates of midpoint, and I know x3 is x1 plus x2 over 2, and y3 is y1 plus y2 over 2. x3 would be equal to 7 plus negative 1 over 2, which is 7 minus 1. 6 over 2 is 3. And y3 will be y1 plus y2 over 3. 3 minus 3, or 3 plus, let me write it up, 3 plus negative 3 divided over 2, which is 0 over 2 is 0. So coordinates of midpoint are 3, 0. X component goes first, y component goes later. All right, next example. Here we have the fractions, but the same thing, we are finding the midpoint. So we have dealt with complex fractions. We know how to deal with the complex fractions. So x3, the coordinates of midpoint are x3, y3. x3 is equal to x1 plus x2 over 2, and y3 is equal to y1 plus y2 over 2. Let's go ahead and find x3 first, which is x1, 1/2 plus, I'm gonna give myself a little more room. x3 is equal to 1/2 plus negative 3/2 divided by 2, which is 1/2 minus 3/2 divided by 2. 1/2 minus 3/2, the denominators are same. So this would be negative 2 over 2 divided by 2. This leaves me with negative 1/2. So that's my x3 here. y3 will be y1 plus y2 divided by 2. 3/8 plus 5/8, which is 8/8 divided by 2. 8/8 is going to equal to 1, so 1/2. So my midpoint coordinates turn out to be negative 1/2 and positive 1/2. Always write the x component first and then the y component. Okay, next example. This one is slightly different. This one says find the other endpoint. We are given one endpoint and we're given the midpoint. So far, we used to be given both the endpoints x1, y1 and x2, y2, and we were looking for the midpoint x3, y3. In this example, we are actually given the midpoint, we're given one endpoint, and we're looking at the other endpoint. So I'm going to label the given endpoint as x1, y1, and the midpoint as x3, y3, and use the same formula. So I know x3 is x1 plus x2 divided by 2. So x3 is 2 equal to x1 plus x2 divided by 2. Let's go ahead and solve this for x2. In order for me to isolate x2, I must multiply both sides with the 2 first to get rid of the 2 from the denominator. So I'm left with 4 equals negative 1 plus x2 because these will cancel each other. And then I would add 1 to both sides. That would give me 4 plus 1 is 5, x2 equal to 5. Now, let's look for y3. The formula for y3 is, actually we're going to be finding y2 in this case. Formula for y3 is y3 equals y1 plus y2 divided by 2. What is y3? Well, that's given to me, it's 5. And y1 is given to me, it's 4. And I'm looking for y2. Now, it's just a matter of solving this equation. I'm going to go ahead and multiply both sides with the 2 first to be able to isolate my y2. Now it's time to subtract 4. 10 take away 4 is 6 equal to y2. Now we can say the other endpoint has the coordinates. X coordinate goes first and y coordinate goes later. That's all in distance and midpoint formula.